So first we have to factor this, and like we did before, it's going to be x minus 5, x plus 1 equals 0. If you're not sure about this, see chapter 1. And then we're going to do split and solve. So it's x minus 5 equals 0, and x plus 1 equals 0. Plus 5, so x equals 5, minus 1, x equals negative 1. Let's do another one like that. In this case here, we could first pull out the x. That's key here. That's what you have to do. You have to pull out the x. And then we could split and solve and set each term equal to 0. So x equals 0 and x plus 5 equals 0. Minus 5, x equals minus 5. So here are our two answers. For this one here, we could factor it out to x minus 4 and x minus 4 equals 0. So now, like we did earlier, we just get x equals 4 and x equals 4. So we just have one answer, x equals 4. This is when we have one solution. When you have an absolute value, it could mean that x plus 3 equals 7, or x plus 3 could equal negative 7. Let me explain. If x plus 3 were equal to 7, then the absolute value of 7 would equal 7. That's good. If x plus 3 would equal negative 7, then the absolute value of negative 7 would also equal 7. So that would work. So what you have to do is you have two different equations, and you have to solve both of them. So one answer is x equals 4, and then for the second equation, minus 3, you get x equals negative 10. And you'll see that both of them work because 4 plus 3 in absolute value is 7, and negative 10 plus 3, that's negative 7, but in absolute value that becomes 7, so that also works. So that's how you solve absolute value. Let's do another one like that. You have to set up two equations. You have minus 2x plus 5 equals 15, but minus 2x plus 5 could also equal negative 15 because the absolute value would make that positive. So then you just solve out both of them. Minus 2x equals 10, and then you get x equals negative 5, minus 5, minus 2x equals negative 20, divide by minus 2, divide by minus 2, x equals 10. Now, if you were to plug in both of those answers into the original, you would see that both of them make the equation true because there's an absolute value there. The key thing here is when you have a radical, you need to do the opposite of what you have. The opposite of a radical is going to be squaring it. So you square both sides, and when you square both sides, the radical and the squared cancel out. So you're just left with x plus 5 equals 15 squared. You should know that by heart. That's 225. Minus 5, so x equals 220. So to get rid of the radical, you need to square both sides. Let's do that again here. So we have a radical. Here we're going to square both sides. We have to always, if we're going to square both sides, you have to square the whole thing. So let me rewrite it so we have more room. We're going to square both sides, but you have to square the whole side. So here, when you square this, you're doing 4 squared, which will be 16, and then radical x squared would just be x. And then same thing here, it would be 2 squared, which would be, well, I'll just write it out, which would be 4. And then radical x plus 4 squared, which would just be x plus 4. But the key thing here is to leave the x plus 4 in parentheses because that's a unit that's together. And then what you need to do is distribute the 4 out. So you get 4x plus 16. That's a mistake that people made here. You need to know to keep the x plus 4 in parentheses when you square it. We'll go over a little bit more the rules of exponents in the exponent chapter. So if you're not sure about the rules here, then don't worry about it. We'll get to it a little bit more, but now let's just finish solving it out. So you have 12x equals 16, then divide by 12, divide by 12. So x equals 16 over 12, which equals 4 over 3. So we'll do another one similar to that in the next exercise, and we'll make sure that you have it down. Here, the way to go with this one is to first quick FOIL this like we did in chapter 1. So that becomes x squared plus 10x plus 25. If you're not sure how to do that, then refer back to the first chapter. And then this one here becomes x squared minus 10x plus 25. And then since we're subtracting the whole thing here, so we need to distribute the minus sign and change all the signs here. Let me rewrite the whole thing. So now what happens is the minus 25 and the plus 25 cancel out. The minus x squared and the plus x squared cancel out. And then we're left with 10x and 10x, which is 20x, and that's equal to 40. Divide by 20, divide by 20, so x equals 2. So what we did here is we quick FOILed this and quick FOILed this. Then we did this minus this. And the only thing we were left with was a 10x here and a 10x here. Remember that we had to change the signs. And then we just solved it out. We'll do another one like that also. Here we need to isolate the x squared. So do minus 2 minus 2. So you have 2x squared equals 162. Divide both sides by 2. And you get x squared equals 81. Like we did before, when you take the square root of both sides, you need to do plus or minus 9. And that works anytime there's an even exponent. We'll see it also applies when you have x to the fourth. So remember, anytime you have an even exponent and you take the root of that, you have to do plus or minus. It'll be a little more clear in a couple of questions when we do it with x to the fourth. Here, what we need to do is when we have a radical, we're going to square both sides. So let's square both sides. You have to square the whole thing on both sides. That's x equals x squared over 16. Because x over 4 squared is x over 4 times x over 4, which is x squared over 16. Cross multiply, so you get 16x equals x squared. Now we want to get this over to the other side, and you'll see why in a second. You have x squared minus 16x equals 0. And we had a very similar question in the beginning of this section where you pull out the x and you're left with x minus 16 equals 0. So then you get x equals 0 and x equals 16, similar to what we did a little bit earlier. And again, we'll do another one of these in set 2. Here we need to isolate the x to the 3. So do minus 2 minus 2. So you get x to the 3 over 5 equals 25. Cross multiply the 5 and the 25 like we've done plenty of times. X to the 3 equals 125. Now you should know that 5 to the 3 equals 125. So then the answer is just x equals 5. The other thing you could have done is, when you got to this point, is you could have, instead of taking the square root, you could have taken the cube root. And then you could type in the cube root of 125 and the calculator would have given you 5. Now we're getting back to that x to the 4 thing I referred to in question 9, I believe. And you'll see what I'm talking about. Plus 2 plus 2. So you get x to the 4 over 4 equals 4. Cross multiply. So you get x to the 4 equals 16. Now here, we know that 2 to the 4 equals 16. Because 2 times 2 times 2 times 2 equals 16. But it could also be negative 2 to the 4 equals 16. Why? Because when you do negative 2 times negative 2 times negative 2 times negative 2, it's going to remain positive. Because this is going to be positive when you multiply that. Then that's going to be negative, but then that will turn it to positive again. So the answer here is x could equal 2 or x could equal negative 2. And what you could have done is when you take the fourth root here, like that, because it's the opposite of x to the fourth, we know the fourth root is 2, but you have to make it plus or minus 2. It would be plus or minus 2. The same way that if we had x squared equals 4, when we take the square root, we would have to do plus or minus the square root of 4. Here we also have to do plus or minus.